right, so for our new topic, let's have a look at what our topic is. Our topic is the nth term in an arithmetic sequence. So let's have a look, see. So an arithmetic sequence is a sequence in which there is a common difference between each term and the previous term. This stays the same and remains constant throughout. We call this the common difference. If we take this first example here, A, we can find the common difference by examining the sequence and seeing that we have a plus 2 happening here, here, and all the way through. We have a plus 2. So this sequence has a plus 2, and the ellipsis here means that the sequence continues to indefinitely, to infinity. Discuss with the people next to you and identify which of the sequences here will be a arithmetic sequence. Which ones have a common difference and which ones don't. I'll give you 5 minutes to have a little look through that one. Okay, so zooming in here. Do we have a common difference happening here? What is it? So we have a plus 2. So this one is arithmetic. I'll put an A here at the end for arithmetic. What about C? This one is not arithmetic. We will see this type later. It's a geometric sequence because we're always multiplying by 10. Adding. Subtract. There's no such thing as subtraction. You just add a negative number. In the same way that with division, you just multiply by the fraction. Yeah, they're reciprocal. Okay, what have we got here? We're adding negative 2. We're adding negative 2. So this one, we'll have a tick instead of an A. That looks much more fun. This one, yes. This one, yes. How about here in E? We're adding 0.5. And F. Are we taking off a quarter each time? What we need to do is if we change this one to 6/4, then we can see it a little bit easier, can't we? And Amelia's right, we're taking away a quarter. So -1/4. -1/4 on that one. This one is arithmetic because we are adding -1/4. That one was a little trickier. Let's have a look at a technique you can do to find the common difference. So if we look at this term here now in a bit more detail, we've got 7/4. Sorry, let me write it like this. 7/4. We've got 3/2, 5/4, and 1, and then ... So we want to have some terminology to describe terms in an arithmetic sequence. So to describe a term in an arithmetic sequence, we use this subscript strategy. So A1, A2, A3, and this is A4. And then we've got our ... The general term in an arithmetic sequence would be A subscript n. What term comes after that one? What term comes after an? Scanned? Again? Yeah. So let me just put in a couple of terms here. So if we want to move more generally, we can have the term an, and then the next term is an plus 1. What about the term that came before that one? an minus 1. Which term comes after an plus 1? An plus 2, and so on. So this generalization is useful for us because when it comes to finding the common difference, d, we have a really useful formula. So you take any term in the sequence and you subtract the previous term, an minus 1. So you take any term in the sequence, such as a4, and you divide, I'm writing gibberish. You take any term in the sequence and you subtract the previous one. I think I was saying the right thing. My pen was just writing it wrong. Like, for instance, if we took a4, we would subtract a3 and we get the common difference. If you do this for several terms, like a3 minus a2, and it comes out to be the same, then you have a common difference. So let me just show that calculation a little bit now. Let me show that calculation a little bit now for you. So this sequence F was a little bit tricky to work with, so I'm going to work with it on my calculator and show you the calculator strategies for this. All right, so if we take these terms, the 5 over 4 and the 3 over 2, take your calculator, take 5 over 4, and then subtract 3 over 2. Notice we get negative a quarter. Take another term in the sequence, like 3 over 2, and then subtract the one before it. Which term came before 3 over 2? 7 over 4. So let's take away 7 over 4 from that one. 7 over 4. Notice that we get the same number coming out here on the right-hand side. This is an indication that there is a common difference happening within this sequence. Let me stay on my calculator screen. So here, is there a common difference here in this one? Let me just quickly check. I've got 3 minus 1 gives me 2. I've got 4 minus 3 gives me 1. No. So G is not arithmetic. Let me switch back over here. Okay, so H. This one gets a little trickier now. Sorry, let me just pause the video. Okay, sorry. Where are we up to? So for H, we've got the sequence here, 5n plus 2. If you're not sure how to do this one, I would recommend making a little table very quickly with some values, turning the formula that we have into a numerical formula by taking the values of n equal to 1, 2, and 3. And then if we put 1 into the formula, we get 5 plus 2, which is 7. If we put 2 into the formula, we get 2 times 5, which is 10, giving us 12. And then 3 5s are 15 plus 2 is 17. What is the common difference happening here? How can you see it in the formula? So what we actually get is if you have a linear formula, if you have a linear sequence, you will get arithmetic. and the common difference is the slope, so to speak. So if you have a sequence, so a arithmetic sequence is always of the form ax plus b, where the common difference is the value a. Geometric ones are exponential. Just as a side note. So if we look at I, what would be the common difference of this one? 3. So this one is arithmetic as well. Whether it would be plus 3 or minus 3 at the beginning. It's that easy. Because for every extra value of n, you're adding 3 to the previous one. Yes, how you see it happening. So what about j? No. This one's geometric. Why? Because it's exponential. And as we see, the common ratio of this one's going to be 2. But we'll see that next week. What about k? What about k? Negative 0.5. So this one is, yeah? And no, this one's not. That one's quadratic, clearly. All right. Ooh. What I want to look at is this. This is what's really important for us today, is this formula. So I'm going to show you where this formula is coming from and how we get this formula. So the formula is given on the formula sheet. My introduction for the next 5 minutes is just so we can understand the big picture of what this formula is and where it comes from. So if we take an arithmetic sequence, it's going to start off at U1. The second term in the sequence, U2, we would make by taking the first term in the sequence and adding the common difference. So if we add the common difference, we'll move between any two terms in the sequence. So just putting this up, if we have U1, and then we have U2, U3, we can get from here to here by adding one lot of D. So we can move along the sequence by adding D each time. But to get to the third term in the sequence, we would have to start from the first term and we add 2 lots of D. So if we get to the third term in the sequence, we start at the first term and we add 2 lots of D. So the third term in the sequence is U1 plus 2 lots of D. To get to the fourth term in the sequence, we would start at the first term and we add 3 lots of D. So the fourth term is U1 plus 3 lots of D. Now we start to see a bit of a pattern. If we look at the pattern between this number here and this number there, what do we see? So if we want to get to UN, we would start at, if we wanted to get to UN, we would start at U1 and add how many lots of D? We would need n minus 1 lots of D. And this is the general formula that we're looking to understand. Let's have a look down here. It's U1 plus n minus 1 lots of D. Because to move to move to the third term, you need to move 2 lots of D along. You're already at the first term, which is why it's n minus 1. You're already at the first term. To get to the 10th term, you need to move 9 steps along. And this is our formula. You will find this on the formula sheet. The common difference is D. We have a formula for the common difference. Let's write it up because it is really important. The common, and this one's not given on the formula sheet, but we can understand it from a conceptual perspective. The formula for the common difference is D equals UN minus UN minus 1. So the difference between 2 consecutive terms. Let's have a go at an example question. This is a typical question. The first term in an arithmetic sequence is 5, and its common difference is 2 over 3. Find the second and third term. So here for A, U1 is equal to, and it tells us 5. It tells us that D is equal to 2 over 3. If we want the second term, it's equal to U1 plus D, which is 5 plus 2 over 3. If we try that on our calculator, we can get 5 2/3, or 17 over 3. If we wish to find the third term in the sequence, we can take the second term and add D to that. So we can take the 17 over 3, and we can add another 2 over 3, which will give us 19 over 3. B. Write an expression for the nth term. What would be the expression for the nth term here? Un is equal to 5 plus n minus 1, 2 over 3. Brilliant. Brilliant. So this question here, C, determine whether or not 49 over 3 is a term in the sequence. So what we could do here for this type of a question, and I've seen this one come up a few times on the exam, is we take 49 over 3 and we set it equal to our general formula. Now, if the solution to this equation using nsolve is an integer, it is a term in the sequence. If it's a non-integer, it's not a term in the sequence. You have to have a whole value of n that we'll get to. Obviously, we can find a value for n using real numbers that will make this equation balance, but it has to be an integer value. So take your calculator now and have a go at solving this equation. Do we get an integer or not? So use nsolve. So what do we get for n? We get 18. What does that imply? It means that 49 over 3 is a term in the sequence. Okay, let's try the last question. Find the first term of this sequence that is greater than 25. So another key skill on this one, and this is where it gets a little bit tricky, is we're going to solve this with an equation. What equation do we want? What equation do we want? (25 equals 5 plus n minus 1 times 2 over 3. Nsolve this. What do we get? Nsolve this one. What do you get? And what does that mean? So, we get 31. What is the answer to the question? Reread the question. So the 31st term is equal to 25. If you look carefully in the question, the wording of the question, it has to be greater than 25. So we want, the 32nd term is greater than 25. What is the 32nd term? Because it says, if we read the question, find the first term in the sequence that is greater. It doesn't want to know its position in the sequence. It wants to know the value. Read the question carefully before exiting. There's a real soft, subtle wording on this one. It says, find the first term in the sequence that is greater than 25. So the 32nd term in the sequence, so we need to insert 32 here. What would this give us? What do we get? 77 over 3. Okay. Any questions on this? I'd like you to have a go at this one for yourself now. Take 5 minutes to have a go at working through this one. Okay. So consider the finite arithmetic sequence. Minus 5, 5 up to 1,189. Write down the common difference. So, what do we get as our common difference? We are having plus 8 here. So, the common difference is 5 minus negative 3, 8. How many terms in the sequence? How do we calculate it? How do we calculate it?
So 1184 is equal to negative 3 plus n-1 times 8.
How much? 150? So why is that? Why is that how many terms there are in the sequence?
Because you're solving for n, which is normal.
Yeah. All right. Let's have a go at a contextual exam style question. Have a go at solving this one. Let's go. All right. So our last problem here is we have the basketball team is playing at a multi-level stadium. We have our ticket pricing. The most expensive tickets are in the first row, and the prices get cheaper after that. So we have to investigate and find the pattern that lies within this data. So what is the common difference that's happening here? Can we find one? Let's calculate it. So we'll start off with D is equal to, and now we have to take 6550 and then subtract the term before it. What does this give us?
Negative 250.
So our common difference is negative 250, and we have to calculate the price of ticket in the 16th row. So we need U16 is equal to U1, which is 6,800. What is it? Plus 16 minus 1 times negative. I'll put a little bracket around the negative 250 so it doesn't look like subtract 250. pop this into our calculator, and we're going to get some number less than 6,000. What do we get?
3,050.
3,050. Like this?
Yes.
And then the currency is yen. Here is our answer to the question.
We can't get marked down for not putting it.
Typically, no, you don't get marked down for not putting the currency. But why be a bad mathematician when you could be a good one?
Oh no.
Can we be good ones?
Sir, can I use the bathroom, please?
Classwork and homework, work with exercise 5J now.